In software engineering, a software development methodology is a division of the software development work into distinct phases or activities, with the intent of better planning and management. It is often considered a subset of the system's development life cycle. Common methodologies include waterfall, prototyping, iterative and incremental development, spiral development, rapid application development, and extreme programming. Some people consider a lifecycle model a more general term for a category of methodologies, and a software development process a more specific term to refer to a specific process chosen by a specific organization. For example, there are many specific software development processes that fit the spiral lifecycle model. ISO IEC 12207 is an international standard for software lifecycle processes. It aims to be the standard that defines all the tasks required for developing and maintaining software. In practice, software development organizations implement process methodologies to ease the process of development. Sometimes, contractors may require methodologies employed. An example is the U.S. defense industry, which requires a rating based on process models to obtain contracts. The international standard for describing the method of selecting, implementing and monitoring the life cycle for software is ISO IEC 12207. A decades-long goal has been to find repeatable, predictable processes that improve productivity and quality. Some try to systematize or formalize the seemingly unruly task of designing software. Others apply project management techniques to designing software. Without effective project management, software projects can easily be delivered late or over budget. With large numbers of software projects not meeting their expectations in terms of functionality, cost, or delivery schedule, it is effective project management that appears to be lacking. Organizations may create a software engineering process group, which is the focal point for process improvement. Composed of line practitioners who have varied skills, the group is at the center of the collaborative effort of everyone in the organization who is involved with software engineering process improvement. A particular development team may also agree to programming environment details such as which integrated development environment is used, programming style details such as use of model-based development, or choice of specific software libraries or software frameworks. These details are generally not dictated by the choice of model or general methodology. Software development activities, planning. Planning is an objective of each and every activity, where we want to discover things that belong to the project. An important task in creating a software program is extracting the requirements or requirements analysis. Customers typically have an abstract idea of what they want as an end result, but do not know what software should do. Skilled and experienced software engineers recognize incomplete, ambiguous, or even contradictory requirements at this point. Frequently demonstrating live code may help reduce the risk that the requirements are incorrect. Once the general requirements are gathered from the client, an analysis of the scope of the development should be determined and clearly stated. This is often called a scope document. Certain functionality may be out of scope of the project as a function of cost or as a result of unclear requirements at the start of development. If the development is done externally, this document can be considered a legal document so that if there are ever disputes, any ambiguity of what was promised to the client can be clarified. Designing. Once the requirements are established, the design of the software can be established in a software design document. This involves a preliminary, or high-level design of the main modules with an overall picture of how the parts fit together. The language, operating system, and hardware components should all be known at this time. Then a detailed or low-level design is created, perhaps with prototyping as proof of concept or to firm up requirements. Implementation, testing and documenting. Implementation is the part of the process where software engineers actually program the code for the project. Software testing is an integral and important phase of the software development process. This part of the process ensures that defects are recognized as soon as possible. Documenting the internal design of software for the purpose of future maintenance and enhancement is done throughout development. This may also include the writing of an API, be it external or internal. The software engineering process chosen by the developing team will determine how much internal documentation is necessary. Plan-driven models generally produce more documentation than Agile models. Deployment and maintenance. Deployment starts directly after the code is appropriately tested, approved for release, and sold or otherwise distributed into a production environment. This may involve installation, customization, testing, and possibly an extended period of evaluation. Software training and support is important, as software is only effective if it is used correctly. Maintaining and enhancing software to cope with newly discovered faults or requirements can take substantial time and effort, as missed requirements may force redesign of the software. History. The software development methodology framework didn't emerge until the 1960s. According to Elliott, the systems development lifecycle can be considered to be the oldest formalized methodology framework for building information systems. The main idea of the SDLC has been to pursue the development of information systems in a very deliberate, structured and methodical way, requiring each stage of the lifecycle from inception of the idea to delivery of the final system, to be carried out rigidly and sequentially within the context of the framework being applied. The main target of this methodology framework in the 1960s was to develop large-scale functional business systems in an age of large-scale business conglomerates. Information systems activities revolved around heavy data processing and number crunching routines. As a framework, a software development methodology is a framework that is used to structure, plan, and control the process of developing an information system. This includes the pre-definition of specific deliverables and artifacts that are created and completed by a project team to develop or maintain an application. A wide variety of such frameworks have evolved over the years, each with its own recognized strengths and weaknesses. One software development methodology framework is not necessarily suitable for use by all projects. Each of the available methodology frameworks are best suited to specific kinds of projects, based on various technical, organizational, project and team considerations. These software development frameworks are often bound to some kind of organization, which further develops, supports the use, and promotes the methodology framework. The methodology framework is often defined in some kind of formal documentation. Specific software development methodology frameworks include Rational Unified Process since 1998. Agile Unified Process since 2005 by Scott Ambler. As an approach, the term software development methodology may also refer to an approach used to apply the software development methodology framework. Specific approaches include 1970s, structured programming since 1969, Capgemini SDM, originally from Pandata, the first English translation was published in 1974. SDM stands for System Development Methodology, 1980s, Structured Systems Analysis and Design Method from 1980 onwards, Information Requirement Analysis Soft Systems Methodology, 1990s, Object-Oriented Programming developed in the early 1960s, and became a dominant programming approach during the mid-1990s, Rapid Application Development, since 1991, Dynamic Systems Development Method, since 1994, Scrum, since, Team Software Process, since, Extreme Programming, since, Approaches. Several software development approaches have been used since the origin of information technology, in two main categories. Typically an approach or a combination of approaches is chosen by management or a development team. Traditional methodologies such as Waterfall that have distinct phases are sometimes known as software development lifecycle methodologies, though this term could also be used more generally to refer to any methodology. A lifecycle approach with distinct phases is in contrast to Agile approaches which define a process of iteration, but where design, construction, and deployment of different pieces can occur simultaneously. Waterfall development. The waterfall model is a sequential development approach, in which development is seen as flowing steadily downwards through several phases, typically, requirements analysis resulting in a software requirement specification, software design, implementation, testing, integration, if there are multiple subsystems, deployment, maintenance, The first formal description of the method is often cited as an article published by Winston W. Royce in 1970, although Royce did not use the term waterfall in this article. The basic principles are: project is divided into sequential phases, with some overlap and splashback acceptable between phases. Emphasis is on planning, time schedules, target dates, budgets and implementation of an entire system at one time. Tight control is maintained over the life of the project via extensive written documentation, formal reviews, and approval sign-off by the user, and information technology management occurring at the end of most phases before beginning the next phase. The waterfall model is a traditional engineering approach applied to software engineering. A strict waterfall approach discourages revisiting and revising any prior phase once it is complete. This inflexibility in a pure waterfall model has been a source of criticism by supporters of other more flexible models. It has been widely blamed for several large-scale government projects running over budget, over time, and sometimes failing to deliver on requirements due to the big design upfront approach. Except when contractually required, the waterfall model has been largely superseded by more flexible and versatile methodologies developed specifically for software development. See criticism of waterfall model. The waterfall model is also commonly taught with the mnemonic "A Dance in the Dark Every Monday," representing analysis, design, implementation, testing, documentation and execution, and maintenance. Prototyping. Software prototyping is the development approach of activities during software development, the creation of prototypes, that is, incomplete versions of the software program being developed. The basic principles are, not a standalone, complete development methodology, but rather an approach to handle selected parts of a larger, more traditional development methodology. Attempts to reduce inherent project risk by breaking a project into smaller segments and providing more ease of change during the development process. User is involved throughout the development process, which increases the likelihood of user acceptance of the final implementation. Small-scale mock-ups of the system are developed following an iterative modification process until the prototype evolves to meet the USERSA Euro unregistered trademark requirements. While most prototypes are developed with the expectation that they will be discarded, it is possible in some cases to evolve from prototype to working system. A basic understanding of the fundamental business problem is necessary to avoid solving the wrong problems. Incremental development. Various methods are acceptable for combining linear and iterative systems development methodologies, with the primary objective of each being to reduce inherent project risk by breaking a project into smaller segments and providing more ease of change during the development process. The basic principles are: a series of mini waterfalls are performed, where all phases of the waterfall are completed for a small part of a system, before proceeding to the next increment, or overall requirements are defined before proceeding to evolutionary, mini-waterfall development of individual increments of a system, or the initial software concept, requirements analysis, and design of architecture and system core are defined via waterfall, followed by iterative prototyping, which culminates in installing the final prototype, a working system. Iterative and incremental development. Iterative development prescribes the construction of initially small but ever larger portions of a software project to help all those involved to uncover important issues early before problems or faulty assumptions can lead to disaster. Spiral development. In 1988, Barry Boreham published a formal software system development spiral model, which combines some key aspect of the waterfall model and rapid prototyping methodologies, in an effort to combine advantages of top-down and bottom-up concepts. It provided emphasis in a key area many felt had been neglected by other methodologies: deliberate iterative risk analysis, particularly suited to large-scale complex systems. The basic principles are: focuses on risk assessment and on minimizing project risk by breaking a project into smaller segments and providing more ease of change during the development process, as well as providing the opportunity to evaluate risks and weigh consideration of project continuation throughout the life cycle. Each cycle involves a progression through the same sequence of steps, for each part of the product and for each of its levels of elaboration, from an overall concept of operation document down to the coding of each individual program. Each trip around the spiral traverses 4 basic quadrants: determine objectives, alternatives, and constraints of the iteration. Evaluate alternatives. Identify and resolve risks. Develop and verify deliverables from the iteration. And plan the next iteration. Begin each cycle with an identification of stakeholders and their win conditions, and end each cycle with review and commitment. Rapid application development. Rapid application development is a software development methodology, which favors iterative development and the rapid construction of prototypes instead of large amounts of upfront planning. The planning of software developed using RAD is interleaved with writing the software itself. The lack of extensive pre-planning generally allows software to be written much faster, and makes it easier to change requirements. The rapid development process starts with the development of preliminary data models and business process models using structured techniques. In the next stage, requirements are verified using prototyping, eventually to refine the data and process models. These stages are repeated iteratively. Further development results in a combined business requirements and technical design statement to be used for constructing new systems. The term was first used to describe a software development process introduced by James Martin in 1991. According to Witten, it is a merger of various structured techniques, especially data-driven information engineering, with prototyping techniques to accelerate software systems development. The basic principles of rapid application development are: key objective is for fast development and delivery of a high-quality system at a relatively low investment cost. Attempts to reduce inherent project risk by breaking a project into smaller segments and providing more ease of change during the development process. Aims to produce high-quality systems quickly, primarily via iterative prototyping, active user involvement, and computerized development tools. These tools may include graphical user interface builders, computer-aided software engineering tools, database management systems, fourth-generation programming languages, code generators, and object-oriented techniques. Key emphasis is on fulfilling the business need, while technological or engineering excellence is of lesser importance. Project control involves prioritizing development and defining delivery deadlines or a item box Caesar euro. If the project starts to slip, emphasis is on reducing requirements to fit the time box, not in increasing the deadline. Generally includes joint application design, where users are intensely involved in system design, via consensus building in either structured workshops, or electronically facilitated interaction. Active user involvement is imperative. Iteratively produces production software, as opposed to a throwaway prototype. Produces documentation necessary to facilitate future development and maintenance. Standard systems analysis and design methods can be fitted into this framework. Agile development. Agile software development refers to a group of software development methodologies based on iterative development, where requirements and solutions evolve via collaboration between self-organizing cross-functional teams. The term was coined in the year 2001 when the Agile Manifesto was formulated. Agile software development uses iterative development as a basis but advocates a lighter and more people-centric viewpoint than traditional approaches. Agile processes fundamentally incorporate iteration and the continuous feedback that it provides to successively refine and deliver a software system. There are many variations of Agile processes. In extreme programming, the phases are carried out in extremely small steps compared to the older, batch processes. The first pass through the steps might take a day or a week, rather than the months or years of each complete step in the waterfall model. First, one writes automated tests, to provide concrete goals for development. Next is coding, which is complete when all the tests pass, and the programmers can't think of any more tests that are needed. Design and architecture emerge from refactoring, and come after coding. The same people who do the coding do design. The incomplete but functional system is deployed or demonstrated for the users. At this point, the practitioners start again on writing tests for the next most important part of the system. Dynamic Systems Development Method, DSDM, Scrum, Adaptive Software Development, Code and Fix. Code and fix development is not so much a deliberate strategy as an artifact of Norvita copyright and schedule pressure on software developers. Without much of a design in the way, programmers immediately begin producing code. At some point, testing begins, and the unavoidable bugs must then be fixed before the product can be shipped. Programming without a planned-out design is also known as cowboy coding. Other methodology practices include object-oriented development methodologies, such as Grady-Buch's object-oriented design, also known as object-oriented analysis and design. The Buch model includes 6 diagrams: class, object, state transition, interaction, module, and process. Top-down programming, evolved in the 1970s by IBM researcher Harlan Mills and developed structured programming. Unified Process is an iterative software development methodology framework, based on unified modeling language. UP organizes the development of software into 4 phases, each consisting of 1 or more executable iterations of the software at that stage of development: inception, elaboration, construction, and guidelines. Many tools and products exist to facilitate UP implementation. One of the more popular versions of UP is the Rational Unified Process. Slow programming, as part of the larger slow movement, emphasizes careful and gradual work without time pressures. Slow programming aims to avoid bugs and overly quick release schedules. Subtopics: View model. A view model is a framework that provides the viewpoints on the system and its environment, to be used in the software development process. It is a graphical representation of the underlying semantics of a view. The purpose of viewpoints and views is to enable human engineers to comprehend very complex systems, and to organize the elements of the problem and the solution around domains of expertise. In the engineering of physically intensive systems, viewpoints often correspond to capabilities and responsibilities within the engineering organization. Most complex system specifications are so extensive that no one individual can fully comprehend all aspects of the specifications. Furthermore, we all have different interests in a given system and different reasons for examining the system's specifications. A business executive will ask different questions of a system makeup than would a system implementer. The concept of viewpoints framework, therefore, is to provide separate viewpoints into the specification of a given complex system. These viewpoints each satisfy an audience with interest in some set of aspects of the system. Associated with each viewpoint is a viewpoint language that optimizes the vocabulary and presentation for the audience of that viewpoint. Business process and data modeling. Graphical representation of the current state of information provides a very effective means for presenting information to both users and system developers. A business model illustrates the functions associated with the business process being modeled and the organizations that perform these functions. By depicting activities and information flows, a foundation is created to visualize, define, understand, and validate the nature of a process. A data model provides the details of information to be stored, and is of primary use when the final product is the generation of computer software code for an application or the preparation of a functional specification to aid a computer software make or buy decision. See the figure on the right for an example of the interaction between business process and data models. Usually, a model is created after conducting an interview, referred to as business analysis. The interview consists of a facilitator asking a series of questions designed to extract required information that describes a process. The interviewer is called a facilitator to emphasize that it is the participants who provide the information. The facilitator should have some knowledge of the process of interest, but this is not as important as having a structured methodology by which the questions are asked of the process expert. The methodology is important because usually a team of facilitators is collecting information across the facility and the results of the information from all the interviewers must fit together once completed. The models are developed as defining either the current state of the process, in which case the final product is called the as-is snapshot model, or a collection of ideas of what the process should contain, resulting in a what can be model. generation of process and data models can be used to determine if the existing processes and information systems are sound and only need minor modifications or enhancements, or if re-engineering is required as a corrective action. The creation of business models is more than a way to view or automate your information process. Analysis can be used to fundamentally reshape the way your business or organization conducts its operations. Computer-aided software engineering. Computer-aided software engineering, in the field software engineering is the scientific application of a set of tools and methods to a software which results in high-quality, defect-free, and maintainable software products. It also refers to methods for the development of information systems together with automated tools that can be used in the software development process. The term computer-aided software engineering can refer to the software used for the automated development of systems software, that is, computer code. The case functions include analysis, design, and programming. Case tools automate methods for designing, documenting, and producing structured computer code in the desired programming language. Two key ideas of computer-aided software system engineering are: foster computer assistance in software development and/or software maintenance processes, and an engineering approach to software development and/or maintenance. Typical case tools exist for configuration management, data modeling, model transformation, refactoring, source code generation, and unified modeling language. Integrated development environment. An integrated development environment, also known as integrated design environment or integrated debugging environment, is a software application that provides comprehensive facilities to computer programmers for software development. An IDE normally consists of a source code editor, compiler and/or interpreter, build automation tools, and debugger. IDEs are designed to maximize programmer productivity by providing tight-knit components with similar user interfaces. Typically, an IDE is dedicated to a specific programming language, so as to provide a feature set which most closely matches the programming paradigms of the language. Modeling language. A modeling language is any artificial language that can be used to express information or knowledge or systems in a structure that is defined by a consistent set of rules. The rules are used for interpretation of the meaning of components in the structure. A modeling language can be graphical or textual. Graphical modeling languages use diagram techniques with named symbols that represent concepts and lines that connect the symbols and that represent relationships and various other graphical annotation to represent constraints. Textual modeling languages typically use standardized keywords accompanied by parameters to make computer-interpretable expressions. Example of graphical modeling languages in the field of software engineering are: business process modeling notation is an example of a process modeling language. Express and Express-G is an international standard general-purpose data modeling language. Extended enterprise modeling language is commonly used for business process modeling across layers. Flowchart is a schematic representation of an algorithm or a stepwise process. Fundamental modeling concepts modeling language for software-intensive systems. IDEF is a family of modeling languages, the most notable of which include IDEF-O for functional modeling, IDEF-1X for information modeling, and IDEF-5 for modeling ontologies. LaPus3 is an object-oriented visual design description language and a formal specification language that is suitable primarily for modeling large object-oriented programs and design patterns. Specification and Description Language, SDL, is a specification language targeted at the unambiguous specification and description of the behavior of reactive and distributed systems. Unified Modeling Language is a general-purpose modeling language that is an industry standard for specifying software-intensive systems. UML 2.0, the current version, supports 13 different diagram techniques, and has widespread tool support. Not all modeling languages are executable, and for those that are, using them doesn't necessarily mean that programmers are no longer needed. On the contrary, executable modeling languages are intended to amplify the productivity of skilled programmers, so that they can address more difficult problems, such as parallel computing and distributed systems. Programming Paradigm, A programming paradigm is a fundamental style of computer programming, in contrast to a software engineering methodology, which is a style of solving specific software engineering problems. Paradigms differ in the concepts and abstractions used to represent the elements of a program and the steps that comprise a computation. A programming language can support multiple paradigms. For example, programs written in C++ or Object Pascal can be purely procedural, or purely object-oriented, or contain elements of both paradigms. Software designers and programmers decide how to use those paradigm elements. In object-oriented programming, programmers can think of a program as a collection of interacting objects, while in functional programming a program can be thought of as a sequence of stateless function evaluations. When programming computers or systems with many processors, process-oriented programming allows programmers to think about applications as sets of concurrent processes acting upon logically shared data structures. Just as different groups in software engineering advocate different methodologies, different programming languages advocate different programming paradigms. Some languages are designed to support one paradigm, while other programming languages support multiple paradigms. Many programming paradigms are as well known for what methods they forbid as for what they enable. For instance, pure functional programming forbids using side effects. Structured programming forbids using goto statements. Partly for this reason, new paradigms are often regarded as doctrinaire or overly rigid by those accustomed to earlier styles. Avoiding certain methods can make it easier to prove theorems about a program's correctness, or simply to understand its behavior. Software framework. A software framework is a reusable design for a software system or subsystem. A software framework may include support programs, code libraries, a scripting language, or other software to help develop and glue together the different components of a software project. Various parts of the framework may be exposed via an API. Process improvement models. A software development process is a framework imposed on the development of a software product. Synonyms include software lifecycle and software process. There are several models for such processes, each describing approaches to a variety of software development process methodologies. Many of them are in the defense industry, which in the US requires a rating based on process models to obtain contracts. The international standard describing the method to select, implement and monitor the life cycle for software is ISO IEC 12207. A decades-long goal has been to find repeatable, predictable processes that improve productivity and quality. Some try to systematize or formalize the seemingly unruly task of writing software. Others apply project management methods to writing software. Without project management, software projects can easily be delivered late or over budget. With large numbers of software projects not meeting their expectations in terms of functionality, cost, or delivery schedule, effective project management appears to be lacking. Capability Maturity Model Integration. The Capability Maturity Model Integration is one of the leading models and based on best practice. Independent assessments grade organizations on how well they follow their defined processes, not on the quality of those processes or the software produced. CMMI has replaced CMM. ISO 9000. ISO 9000 describes standards for a formally organized process to manufacture a product and the methods of managing and monitoring progress. Although the standard was originally created for the manufacturing sector, ISO 9000 standards have been applied to software development as well. Like CMMI, certification with ISO 9000 does not guarantee the quality of the end result, only that formalized business processes have been followed. ISO IEC 15504, ISO IEC 15504 Information Technology A Euro Process Assessment, also known as Software Process Improvement Capability Determination, is a framework for the assessment of software processes. This standard is aimed at setting out a clear model for process comparison. SPICE is used much like CMMI. It models processes to manage, control, guide and monitor software development. This model is then used to measure what a development organization or project team actually does during software development. This information is analyzed to identify weaknesses and drive improvement. It also identifies strengths that can be continued or integrated into common practice for that organization or team. Formal methods. Formal methods are mathematical approaches to solving software problems at the requirements, specification, and design levels. Formal methods are most likely to be applied to safety-critical or security-critical software and systems, such as avionics software. Software safety assurance standards, such as DO 178B, DO 178C, and common criteria demand formal methods at the highest levels of categorization. For sequential software, examples of formal methods include the B method, the specification languages used in automated theorem proving, RAISE, and the Z notation. Formalization of software development is creeping in other places, with the application of object constraint language and especially with model-driven architecture allowing execution of designs, if not specifications. For concurrent software and systems, Petri nets, process algebra, and finite-state machines allow executable software specification and can be used to build up and validate application behavior. Another emerging trend in software development is to write a specification in some form of logic, usually a variation of first-order logic, and then to directly execute the logic as though it were a program. The OWL language, based on description logic, is an example. There is also work on mapping some version of English automatically to and from logic, and executing the logic directly. Examples are attempt-controlled English, and Internet business logic, which do not seek to control the vocabulary or syntax. A feature of systems that support bidirectional English logic mapping and direct execution of the logic is that they can be made to explain their results, in English, at the business or scientific level. See also, computer-aided software engineering, domain-specific modeling, lightweight methodology, list of software engineering topics, list of software development philosophies, object modeling language, structured programming, development methods, chaos model, extreme programming, iconics, incremental funding methodology, model-driven engineering, service-oriented modeling, software prototyping, specification and description language, top down and bottom up design, unified process, user experience, V-model, verification and validation, related subjects, Bachelor of Science in Information Technology, best coding practices, conceptual model, continuous integration, cost estimation in software engineering, IPO model, list of software development philosophies, method engineering, outline of software engineering, performance engineering. Process, programming paradigm, programming productivity, project, rapid application development, service-oriented modeling, software design, software development, software documentation, software release life cycle, systems design, systems development life cycle, test effort, references. External links, selecting a development approach at cms.hhs.gov. Software Methodologies Book Reviews. An extensive set of book reviews related to software methodologies and processes, Gerard Fisher, The Software Technology of the 21st Century, From Software Reuse to Collaborative Software Design, 2001, slides with methodology thumbnails and comparisons.